Public cloud may be more secure than your data center because the cloud service providers have a significant incentive to provide a secure infrastructure for their customers. And so they invest heavily in their security, and this is demonstrated through pre-certification across many compliance frameworks. And the reason why they invest in it is that confidence that customers can deploy their applications on the public cloud in a secure manner. So to understand how that works, though, is the shared responsibility model. And the shared responsibility model separates the cloud responsibilities. The cloud service provider is responsible for the security of the cloud, while cloud consumers of the financial organization is responsible for security in the cloud. And how that looks in an IaaS type of environment or a service delivery model is the service provider is responsible for updating the host operating system and the virtualization technology to eliminate any threats from that perspective, where the customer is responsible for just the host operating system. And then the other aspect of that is the inherent security built into the cloud. So to isolate different environments, the cloud allows you to build out your different multi-account framework, such that you can have an account for production and testing and development. And creating accounts costs nothing. It's what you put inside of them that actually starts to build up the cost. So what that does, that a multi-account creation isolates the blast radius in case one of those accounts are compromised. And then you go a step further within each account, you can set up virtual private networks such that if a particular application is compromised, the blast radius is limited to that particular application. And finally, you can go even further into microsegmentation using subnetworks and then software-defined network constructs like security groups to further isolate your blast radius. The benefit of leveraging the cloud then in terms of security is through the shared responsibility model, you can shift the security controls or many of the security controls for the infrastructure over to the cloud service provider, where they take care of the hardware and software patching and the compliance frameworks, or at least the initial platform compliance. And that provides the cost efficiencies because you can focus on application, not infrastructure. And finally, by the inherent security of the cloud, you can limit blast radius by implementing multiple accounts, which you couldn't do in your local data center because you're not going to spin up a physical data center per application.
So almost every cloud service provider offers some way to code the underlying cloud architecture. Storing the infrastructure as code in a version-controlled repository has several advantages. Whereas you're able to spin up and spin down individual virtual machines with immutable deployments, you're also able to completely destroy entire cloud architectures and re-provision them for no other reason than to create a simple refresh or a reset of the entire cloud infrastructure to a state that you know is compliant and secure to the standards of the financial institution. Because you have to remember, everything in virtually everything is virtualized in the cloud. So the only way to access them is through some sort of console. And it can be very tempting for any member of any operations team, for example, to go in through that console and start clicking around and configuring things to the way that they see fit. But with infrastructure as code, all these changes are clearly documented, and any delta between any two given points in time can be observed. Combined with integrating this into some sort of software development lifecycle, or offloading the infrastructure code bit to its own SDLC and exposing the infrastructure changes to additional security scanning and tools, this can form one of the main foundations of operational excellence. If you look at traditional on-premise systems and you consider the concrete example of distributed denial of service, or DDoS, handling something like that can be a bit challenging with traditional on-premise architectures. A DDoS attack is where attackers attempt to overwhelm and overpower the resources provisioned in your network architecture, and they target your infrastructure until the services that you provide are no longer able to cope with that demand, rendering your service unusable. With traditional on-premise systems, that can be challenging in the sense that dynamic scaling of your resources is not as easy because they are physically located in your data centers. You'd have to have dedicated hardware and dedicated software. You'd have to configure them to scale to the DDoS attacks, and you'd have to have internal resources dedicated to performing those tasks. But with cloud service providers, there are solutions that can easily mitigate those kinds of attacks. For example, you have automatic scaling or horizontal scaling of virtual instances to absorb these types of attacks so that your application can continue performing to the standard that the financial institution likes, but then you also have the ability of provisioning a content delivery network whereby these attacks could be diverted to different edge locations around the world. And again, this would allow your application to just continue performing at a good pace. Well, traditional on-premise systems, you would need dedicated hardware and dedicated software to deal with these types of attacks. You would have to also allocate internal resources to perform these configurations to mitigate, any type of attack as well. And dynamically doing so in a traditional on-premise system is obviously challenging because of the static nature of the architecture. Whereas with the cloud, you have some solutions such as auto-scaling, where you could scale the number of instances of your application to absorb the attack that's being conducted on your system. Or some cloud service providers offer CDNs, content delivery networks, whereby the attacks are diverted to different edge locations. If you look at financial institutions' login page, for example, attackers could continuously hit that login page to the point where it overwhelms the API, and from that standpoint, the overwhelming traffic on that API endpoint would render the page to be basically unreachable because of the increased demand in network traffic.